Hi, I'm Mr. Kangas, and today we're going to be taking a look at Chapter 11, Section 6, similar 3D solids. So basically, if you remember the chapter on similar figures, I believe that was back in Chapter 10. This is exactly the same thing, just instead of using 2D figures, we're now using 3D figures. But the same concept applies, it really isn't any different. Before, if you had, for example, similar rectangles, and let's say we had a side of 3, 5, x, and 6, you would take your corresponding sides and you could create fractions out of them. So we have a 3 to 6 ratio with those two corresponding sides. If I told you these rectangles were similar up front, you could do this. And then since we have a 3 over 6, so the 3 is over the 6, so the 5 would go over the x. And if you recall correctly, we don't need to have the measurement of every single side, just as long as you have at least 2 measurements, and you have to have one completed corresponding pair. So the 3 and the 6 don't have a variable, so we have a completed fraction, so we now know the ratio between the two sides is a 3 to 6 ratio, or if you reduce it, it reduces down to a 1/2 ratio, or 1 to 2. So basically the way similar figures work is that all corresponding sides share the same ratio. So if there's a 1 to 2 ratio between the 3 and the 6, then there's a 1 to 2 ratio between the 5 and the x. Now, some of these ratios are going to be really simple. As you can see, this is a 1 to 2 ratio or a 3 to 6 ratio, but fully reduced it would be a 1 to 2 ratio. That's a very simple ratio. That's something that you can probably look at this problem and you can already tell me what x is supposed to be. That's not the purpose of this problem. I don't want you doing this stuff in your head. What I'm about to show you, once again, is how to do this no matter what the ratio is. Sometimes you may have a 7 to 13 ratio going on here, at which point you'll have no idea what x is, and you'll need what I'm about to show you. So make sure you take notes, and please refrain from doing this stuff in your head, because eventually you will face problems where you won't be able to do it in your head. If you pay attention to what I'm about to show you, you can accomplish any problem. And the reason why I am not showing you this on 3D figures, such as this pyramid, is because the concept is exactly the same. You're just looking for corresponding sides. You're going to find the ratio that exists and then use that ratio to find the missing piece. The steps are exactly the same, and if after this video you're still confused on how to do this on a 3D figure, raise your hand and ask. I'm pretty sure once I show it to you, it's going to be one of those moments. This is one of those things in math where we tend to overcomplicate it. We think it's got to be harder than it actually is, but it really is it's very simple. Okay, so I'm going to move my squares over a bit. So here are my rectangles. Here's a rectangle. Here's a rectangle. So we had a 3, a 6, a 5, and an x. Okay, so here are my two fractions representing the corresponding sides. The key thing to remember is, since all corresponding sides share the same ratio, that means all the corresponding sides create equivalent fractions. Okay, so this 3/6 should be equal to this 5 over x, because these are equivalent fractions, because I told you ahead of time these were similar rectangles, and so you know that the corresponding sides create the same ratio, or in other words, equivalent fractions. Okay, so they both share a 1 to 2 ratio, as we can see, because if I reduce this 3/6, it reduces to 1 to 2. So you could set this up as 3/6 equals 5 over x. Since 3/6 can be reduced, however, I'm going to reduce it before I start. So I'm going to reduce it to that 1 to 2 ratio. Okay? And so what you do at this point is you cross multiply. You do 2 times 5, which is 10, 1 times x, which is x. Okay? So in this case, it's really simple. We already know what x is. X is 10. 5 over 10 is equal to 1/2, which is equal to 3/6. Okay? Sometimes what's going to happen, sometimes instead of having a 1 up here, you might have something like a 3. At which point you'll have 3x, and in order to figure out what x is equal to, you'll have to solve a one-step equation. So in this instance, I would have to divide both sides by 3 and find out that x is actually 10/3 or 3.333333 if I finish the problem. Okay, so sometimes you'll have to do a one-step equation. Sometimes, like this instance, it's just a matter of cross-multiplying. Sometimes you'll have to cross-multiply and then solve a one-step equation for x. Again, this is no different process than what you would do with 3D figures. It's just, for some people, it may be a little bit more difficult to figure out which sides are corresponding on the 3D figures. On the 2D figures, there's not as many sides to have to toy around with. With the 3D figures, some people may get confused, and if you need help with that, please let me know. So in my next video, I'm actually going to talk about why it is when you cross multiply, like for example, when I have 3/6 equals 5 over 10, why is it when I cross multiply, so I do 3 times 10 and I do 5 times 6, why do I always get equivalent answers? That will be in my next video. So if you want an explanation for that, please stay tuned to watch it.